Hello, welcome to Solidworks video tutorial. In this video tutorial, we are going to see circle and spline tool options. Now, first of all, I have selected one plane as my reference plane for sketching. Now, I will show this circle command. In circle, there are two types of circle. In the first circle, we have to define its center as well as its radius. So I selected the center and then I select radius as 50 mm. Then I entered, the circle gets generated. Now, second type of circle over here is parameter circle. For this circle, we have to define 3 points on circumference of this circle. Now, first of all, I delete this circle. Now, suppose I select this point as my first point, this point as my second point. Okay, so this is general type of circle. It means circle with center and radius. The second type of circle, I will click on this circle, then I will select this as my first point, this as my second point, this as my third point. Okay, so in this way we can generate different types of two types of circle, basically a circle with center and radius, and this is parameter circle. Now there are other option, that is for construction option. Similarly, we have seen this option in line command. Similar option is over here. Okay, similar option in this circle also. We can also fix this circle. Once we fix this circle, this geometry will turn, that is fully defined. Fully defined geometries and underdefined geometries, we will see this in next video tutorial. It is very important tool, or it is very important to understand what do you mean by fully defined geometries and underdefined geometries. Now we'll see the spline command. Now in spline command we have three different types of commands: spline, style spline, and equation driven curve. In this video tutorial we will see all these type of commands. Now in spline command, first type of spline command, we generally draw this type of splines. Now you will think, what is use of this kind of splines? Now we generally use this kind of splines in order to generate a surface. Okay, so suppose this is surface tool over here, you can see. Now I select this surface tool, I select extrude surface, and this spline is automatically selected. I selected mid plane, and then this surface get generated. As you can see, this surface is basically a very thin. Okay, it has zero thickness basically. Okay, we'll see this surface tutorials later on, but we have seen the use of spline for particular operations. Now we'll see the second type of spline, that is style spline. I select front plane as my sketching plane. Then there are 3 to 4 types of this style spline. A Bezier, the B spline of degree 3, B spline of degree 5, B spline of degree 7. Now what do you mean by degree? Degree is number of independent coordinates required in order to fix the geometry. Now here you will require 3 different points. Here you will require 5 different points. Here you will require 7 different points. Now this is basically simple type of Bezier spline we have drawn, and you may use this type of splines whenever you require. As I explained, in generating the surface we can use this, and surface tools we can use this type of splines. Now third type of the spline is equation driven curve. Now equation driven curve, there are two types: explicit and parametric. Now what is explicit? We will first learn explicit. Explicit means you have to enter the y as some function of x. Suppose I enter y as sine x. Now sine, you have to enter a bracket, and inside the bracket you have to enter x. Now you have to choose the value of x. Suppose I choose value of x from 0 to not 0, I choose some 2 and then some 5, and then just click OK. Now you can see this curve is generated. Now how this curve is generated, we will understand. We will select dimension and we will measure its dimension with respect to origin. As I already told, this point is represent origin. This is second point. The distance of this point with respect to this point will measure, and we can see over here that this curve we have generated of sin x type, and with x1 equal to 2 to 5. It means the x coordinate of this curve is 2 and the end point is 5. Now we'll see other type of curve. similar like sin x, but suppose 4 sin x, 4 sin x, and x from 2 to 5. Then similar type of equation is invalid. Please enter a valid equation. It means you have to specify your multiply sign. Okay, and then click OK. Now you can see this type of curve is generated. Now you can again measure these dimensions. This is 2. I have specified 2 comma 5. So again the curve nature is changed because it's 4 sin x type of curve. 4 sin x type of curve. Okay, the 2 and 5 remain as it is. Now the other option in equation driven curve is parametric curve. Now we'll see this. Let us first delete this geometry. Now equation driven curve in parametric mode. In parametric mode the equation is written as a function of time. A parametric equation is basically a function of time equation. Now x has some function of t, suppose this is t, and y is some function of t square, means it is parabolic curve. It will be parabolic curve. Now first point is x is t and second is x is equal to t and y equal to t square. Now t starts from 2 to 5 and then just click OK. Now this type of curve is generated over here. Now we'll select again, we'll measure this with respect to origin, and we see that this is 2, which is x coordinate. Y coordinate of same point is 4. Second point x coordinate, y coordinate is 25, and x coordinate it will be by default, which is 5. Now you can see this curve we have entered x equal to t and y equal to some t square. Now when you will use t1, that is here it is 2, so x will be equal to t, that is x will be equal to 2, and y equal to t square, that is 2 square, that is 4. So first point will have coordinates 2 comma 4, x coordinate 2, y coordinate 4. Similarly second point will have coordinates x equal to t, that is 5, second t2 is 5, that's why x equal to 5, and y equal to t square, that is 5 square, that is 25. So you can see here it is 5 and 25, 5 comma 25. So in this way curve is generated, and it is parabolic in nature because y is parabolic in nature. Now in this way we can generate the equation driven curve, styled spline and spline in Solidworks. I will see other sketch tool option in our next tutorial. That's all. Thank you.